In this video, we're going to concentrate on the modulation section in the center of the front panel here. Now, the modulation section really houses two different LFOs. Now, actually, if we come to the back panel, there is an LFO steps section here as well. Now, we're going to treat that separately when we look at the back panel, so we're going to come back to that aspect of the LFO. But first of all, what's important to note is there's two different LFOs here. So if we select LFO1, you'll see the parameters that relate to LFO1. We click on LFO2, you'll see the parameters now change to be those that are working for LFO2. So we'll leave it on LFO1. You can see they're identical, but obviously we can have different parameters set up for each one. Okay, so first of all, we have a rate control. Now the rate control is going to determine the speed of the modulation. And before we get into that, what is an LFO? An LFO is a low frequency oscillator. So we know oscillators are what are used on the synthesizer to create the sound. This is a low frequency oscillator because an oscillator can create frequencies between 20 hertz and 20 kilohertz, 20,000 cycles per second, 20 cycles per second to 20,000 cycles per second. And if you think about the lowest note we could potentially hear is 20 cycles per second. That's quite fast. So a low frequency oscillator works on low frequencies, i.e. frequencies generally below the human hearing range. This one goes up to 22 hertz, so slightly above potentially the lowest point of the human hearing range. But it operates in that lower area because we use LFOs for things like vibrato, tremolo, wah-wah effects. And for us to be able to actually hear those as being kind of an independent modulation or an independent movement, they need to be fairly slow because even 20 cycles per second is quite fast. Think about a guitarist bending a string or a violin player bending a string. To do that 20 times per second is quite fast. So generally, effects like vibrato are going to be a little bit slower than that. Okay, so the LFO rate is going to be, as I said, the speed of the LFO. Now, let's actually route this to something so we can hear it in action. I'll put it on the filter, which is often a good one. Let's bring the envelope amount down. In fact, let's just reset the sound. Should be an easier way to do this. So we'll add this to the filter here and make sure the envelope amount's down. That means we're just going to hear this working on the filter. Now what we need to do is increase the depth here. And we can hear that trademark filter wobbling sound. So you can hear the rate working there to speed up and slow down that periodic modulation. Now this is working in hertz. It's working with the shape of a sine wave. So this is not currently locked to the project tempo. Let's move this to a square wave. So we can hear the difference there. So a little bit of a sharper kind of sound, not as rounded as the sine wave. Now the next one we have is sample and hold. This is a kind of a randomized waveform. So it basically takes a sample of the waveform and then holds it. Speed it up a little bit. So a really nice effect. Now, as I said, the back panel houses the LFO steps section. To be able to utilize that, we need to actually have the LFO steps button selected here. And you'll notice that when I do that, this control here now updates to show us beats and bars for our rate control. So now we can actually change the speed of the LFO in beats and bars against the project tempo. Whereas these ones are all measured in kind of a free hertz control where we can just drag and it's not stepped. Whereas this one is stepped, you can see it changing there. But as I said, we're going to come back to the LFO steps when we look at the back panel. Now the depth control we've kind of touched upon. This is going to be the amount of modulation. And then just across to the right, we have a series of different kind of hardwired destinations or, quickly accessed destinations. So we looked at the filter there. Let's take it off the filter and put it onto oscillator 1. So now we're working on the pitch of oscillator 1. Let's bring in oscillator 2. Now we're working on the pitch of oscillator 2. I was just changing it up so it sounds a bit different. So using these buttons, we can just quickly route the LFO to affect that parameter. Now, right at the beginning, when we had a look at the oscillator section, we had a look at the pulse width. So let's just recap on that. So we can use that to change, put this onto a pulse wave here. We can use that, as I said, to change the pulse width using this LFO. You can hear that in action there. So it's just modulating essentially the width of the pulse stroke square wave to give you that trademark kind of modulating sound. And those are the parameters of the modulation section. Now, when we come to look at the back panel, you'll notice here that we can use the LFO within a modulation matrix, which is a bit more kind of traditional way of routing things around in modern synthesizers. And as I said, we also have the LFO steps section we're going to come back to. But for now, we'll leave it there for modulation section. So just to recap, 2 LFOs, remember, they're identical. The rate control is the speed of the LFO modulation measured in hertz. The shapes can be sine, square, or sample and hold. And then the LFO steps relates to the back panel. We have the depth control here to determine the amount of modulation that's going to take place. And then we can quickly route this to the pitch of oscillator 1, oscillator 2, or the filter cutoff, and also the pulse width of oscillator 1 and 2. Okay, so now we've covered the modulation section. In the next video, we're going to head up to the top here and we're going to have a look at this top panel and taking these 3 sections in turn. So I'll see you then. Thanks for watching.